Hello and welcome to QED Stata 4, starting from part S8. And now we're in Yangon, looking at the situation with street vendors. And this is based on stories about policy changes by the Yangon City Development Committee, where they're trying to tighten up on regulations. Because even though it's obviously a useful part of the economy, it's also causing some problems in terms of waste and health and safety issues and so on. So we're going to use the sample data to test the accuracy of this figure here. I think maybe what I should have done previously is just take the time to write out these hypotheses, because you need to get into the habit of writing hypotheses in a reasonably precise sort of way. So what we're looking at here is the null hypothesis is saying that so we're looking at the mean value daily sales year 21 last year. That's 2019, yeah. 7250. Okay, so that's the null hypothesis, but the alternative, and what I suggest being lazy when you write alternative hypothesis, because the idea to make it as precise as possible, you want to copy that. The alternative should be as close as possible to the null hypothesis, just changing what you really need to change to emphasize where the difference is. And here the possibilities are the alternative could be less than that, or it could be more than that, or it could be not equal to that. And here we're trying to test the accuracy. So because we're testing the accuracy, if our sample value comes out well above this, we're going to reject it. Also, if it comes out well below this, we'll reject it. So the alternative was not. So they're almost identical, except for this is was not. So it's a two-sided alternative. So let's test the accuracy. We need to find this data and just grab the data. Okay, this is the last bit of data on this sheet. I'll just save time by doing both these together. So later you'll find a slightly quicker way of doing this in the World Value Survey part. There's a quick way of typing this last command, but let's just do it along with no details. And actually, no, this. That's because that nice comparison like this. So there's a suggestion here that mean income's gone up. We're going to test that in a minute. Let's just get a bit more detail just on the 2019, which we're looking at the moment. So they reckon in null hypothesis it's going to be 7250. So it's above that here. So the traders null sample are earning more than that. But it's not a massive sample. There's a lot of noise in the data. You can see the standard deviation is that. So double that gives you an idea of where most people should be. So it's within like 6,000 or 60,000 of that. It's a massive range of what traders are earning. So it may well be that this difference between that and the claim, by the way, the YDCDC is not significant. Let's test it. So test is going to be using this test value 72500. Let's see what the status is going to tell us. And we're looking for accuracy again, so it's the middle one here. So this is telling us that if it's true that among all the street traders the mean income is really, or the mean sales is really this every day, then the chance of us selecting 29 street traders at random and finding that the mean is as far away from this, either above or below as that is there, the chance of that is 41%. So a pretty high chance. So if this is the thing I'm believing, then my chance of seeing this data is about 41%. So that's a pretty high chance. I'm quite happy to carry on believing what I believe. So there's no evidence there at all to reject the null hypothesis. So the answer in this case is we certainly can't reject the null hypothesis. There's really no there's no evidence there to suggest that the right CDC figure is not accurate. Okay, so we stick with the null hypothesis. Okay. As I intimated there, looking at the comparison of 2016-17, is it true that it's been inhibiting the growth of sales among the street vendors? Are they still managing to grow their sales, even despite the fact that the regulation is getting tighter? So one way we can do this is if we take the mean sales level as it was in 2016, and then do a t-test to see if the 2019 sample has gone up. So that's just, I've already got that number for you. That's up here, so it was 72084. So 72084 was the mean. That's a bit low, I might be able to show that. So if we take that number there, copy that. So what we do here is that we have the null hypothesis now will be the mean value of daily sales among all street vendors in 2019 was still, it will be that value there. That's the mean that we calculate. If we assume that was a correct mean in 2016, which is a big assumption, and then here, instead of this, we want to see if it's gone up. So it would be so now we're doing a one-sided test to see if there's evidence of rising sales levels. So if we'd found it below, we wouldn't reject it. We would only reject if we find it higher. So we want to know what's the chance of getting the mean we did get, which is considerably higher than that. In that case, we need to do the t-test. So pretty much repeat this t-test just had here, except that second figure now is going to be the mean figure back from 2016. Let's see if we can reject that. Okay, so if that really was, so if in the whole, the idea is that, say in the whole population the mean is still what it seemed to be back in 2016, the chance of selecting 29 people getting a mean this far above it now, because it's one-sided, is 18%, so it's less, but 18% is still, it's not a tiny probability, so that could quite easily turn up. So again, there's no real evidence here that the overall level of earnings has increased based on that test. So I can't reject this null hypothesis either in favour of this one. So no, this method doesn't give us any indication that sales have increased on that previous level. Okay, before we finish this part, there's another way we can do this, which is to create a new variable, and the new variable's got to show for each income, for each trader, how would their income rise. Now, that's part S10. The way to do that is use that gen command that you've had before. I was going to put sales rise. And this is where you put equal because you're making something equal, so it's just one equal sign. And it's going to have to be equal to so it'll create a new column of numbers in the data, which is called sales rise, and it takes the sales in 2016 away from the sales in 2019. So if anyone's lost money, that will be negative. But let's just do that. It's worth making really sure. I'll put browsing just to make sure you understand what's happened there. Oops, come on. Here's the data. So that's the data we started with. Now it's calculated this. So this last column is the increase in earnings among all these 29 traders. We can see that like the first one, poor thing, is earning less money than she was before, and she's earning more. There's a few that are earning less. Okay. The principle of the t-test we're going to do now is that if on average there's been no change in people's incomes, then the average of this last column should be 0. On the other hand, if the average of this last column is bigger than 0, that indicates that on average incomes have been going up. So all we're going to do, I think this is indicated. Yeah. But this here is basically looking at that, looking at the average of that new column of the differences to see is it equal to 0, or possibly it could be bigger than 0. So if you want to put some hypothesis in, the hypothesis would be that there's been no change, in other words, the mean of that column would be 0. The alternative is that there's been an increase in people's income, so the mean of this column will be bigger than 0. So it's a one-sided test. So we're going to run that command now. I'm going to find a way back to stata on all these windows. It's always, for this kind of thing, test, it's always equal to 0 is the null hypothesis. So the alternative is bigger than, over here, it's actually 0.0. It's very significant, so it's well under 1%. So if the null hypothesis is true, and there hasn't been a rise, then the chance of selecting 29 people and finding that the average of each of their individual rises is as big as what you found it was. That's the mean actual rise, comparing each person with their situation 3 years previously. The chance of finding a mean rise as much as that is less than 1%. So here's really strong evidence. We reject the null hypothesis with 1% significance level. So using this test, it's found there is strong evidence of an increase. And this test is more powerful than the previous test, the previous approach, because the previous approach is essentially throwing away the information that the data we have is matched. You have data on each person's individual change rather than just the whole overall average for 2016 and the overall average for 219. You've got the individual matched things, and we can see from the column of data that when you match it up, even though the actual size of the increase is pretty small, the chances of so many of them being positive and so few being negative, so you get this overall positive result, the chance of that happening if the overall level hasn't changed is very, very small. It's less than 1%. There's another very simple test you can do, which is just to look at how many positives and negatives. And if you get way more positives than negatives in here, that's another way of showing that there must have been upward movement. That's called the sign test, as in positive and negative signs. So this way of doing the t-test is called a paired t-test. And it's very useful when you have data on the same individuals, and remember the individual could mean people or households or fish or trees, the same individuals before and after, for example. If you've got things which are paired together, then you can subtract them and take your null hypothesis that the mean difference is 0. And then you can either have a one-sided, two-sided alternative. That's a much more powerful test. You're much more likely to find any difference that really is there in the population. So the results do show us that incomes have risen, and compared to the previous test, it's a much more powerful test that's managed to reveal something the previous test didn't guess at. And that's called a paired t-test. Okay, so that's enough of those simple examples. In the next section of this, we're going to work with some much bigger and more complex real-world data. But for now, thanks for watching.